All right, guys, so we're going to be reviewing things about congruent triangles. So the different shortcuts that we have, congruent statements, those kinds of things. All right, so congruent triangles. So let's just kind of remember what it means for two triangles to be congruent. So when two triangles are congruent, it means one, all corresponding sides are congruent, and two, all corresponding angles are congruent. So that's a lot. That's actually, right, three sets of sides, three pairs of sides, three pairs of angles. That's six things. Here we have a picture of some congruent triangles that are all marked up. You know, a lot of times when we deal with problems involving triangles or congruent triangles, we're not going to have all of these markings. So it could be a little more complicated than this, but usually we can identify the easier ones, the corresponding parts that are marked quite well. So here we have side AB and side ED would correspond. And we would have, so AB would correspond with DE. And we have, let's see, side AC here would correspond with side DF. AC would correspond with DF. And then finally, BC would correspond with EF. BC would correspond with EF. And obviously, I got to add a little bit of extra notation on this. Right, these are all segments, so we want to mark those as segments. And these should be congruent symbols here. So I'll put a little squiggly there for a congruent symbol. So, you know, all we did was match up which parts had the same markings on it. And for the side, I'm just using these tick marks. So side AB, DE, side DF goes with side AC, and side BC went with side EF. Same tick marks, they're congruent to each other, they correspond with one another. That can get a little tricky if perhaps two of the sides within one triangle were congruent, if we were dealing with an isosceles triangle, but we'll leave that. What are the corresponding angles? So same idea here. We're just going to match up the same angles, the ones that are marked the same. So we have a single arc here and a single arc here. So we'd say that angle B is congruent to and corresponds with angle E. Angle A has double markings. That goes with D. So angle A is congruent to and corresponds with angle D. And then the last one, three markings and three markings. So angle C is congruent to and corresponds to angle F. Pretty easy. Again, we're not always given all this stuff, so we have to sometimes do some things to figure stuff out. So just to kind of show this a little bit, some other things that we could do. We could say, if we know that angle A and D correspond to one another, then the sides that are across from those angles would also have to correspond. So that's another way to find corresponding sides. Is if we know we have these two angles that correspond, then BC would have to correspond to EF. And we did see that here when we wrote out the sides. Similarly, we could kind of do it with like another way would be something like, all right, we know that these two angles correspond with these two angles. And so the sides between them would have to correspond. So AB would have to correspond to DE. And we can see that right there. So a lot of different ways that we can figure it out without necessarily using the markings, because perhaps we won't be given all of these things. All right. Next thing we did was congruent statements. So a congruent statement is like this statement right down here. That triangle LMN is congruent to triangle VRT. Turns out, really important, the order of the names actually matches up with which parts correspond with each other. The easy part is the angles. So angle L, angle V, those would correspond. They're the first letters in the names. The second letters, angle M and angle R. Angle M would correspond and be congruent to angle R, and then angle N and T, because those are the last letters. So angles are pretty easy. Now this can get a little tricky if we had a situation where we were dealing with, say, two triangles that like shared some parts and stuff, and sometimes the names can get a little funky. Like if we have A, B, C, D, right? These two letters are parts of each triangle, and maybe they correspond with one another, or maybe it's something like this, right? So that this angle A actually corresponds with this angle C, and then vice versa. This angle A up here actually corresponds with this angle C. So the naming can get kind of weird when we have situations like that. But for right now, we're going to keep it simple. All right. Here, we use the names to find the matching angles, the corresponding angles. The sides can be done pretty similarly, right? So side LM, the first two letters, would actually correspond with side VR, the first two letters there. The second two letters, MN, RT, those would correspond with one another. And the other side we're missing here is LN. That would correspond to VT. Pretty easy to do it that way. Again, we're just matching up what letters in the same position. People find this side part coming from the congruence statement to be a little trickier, though. Some people may prefer to sketch out just some kind of generic triangles. So I'm just going to draw two triangles that I could use to sort of help me out with this process if I wanted to. So these triangles are going to be congruent to each other because that's what we're talking about. And I'll just go ahead and name them. So this one would be L, M, N. Now I don't know what these triangles look like. These triangles are just used to sort of put the letters on a figure to help me sort of visualize this better. It's just about relative positioning. It has nothing to do with what the actual size and shape of these triangles would be. We just know that they're the same. So we drew two triangles that were the same just to sort of help us figure out which parts go together. But now, with this visual representation of our congruent statement, it's a lot easier to see that, yeah, these two sides go together. So that's this statement. And MN would go with RT, which that statement, and then LN would go with VT, right? It's a lot easier to see it perhaps in this visual form instead of kind of matching up the letters that way. It's up to you. This way obviously takes a bit longer and can kind of be tedious if it's just a small part of the problem that we're trying to do. So I recommend trying to be able to go from here to here, but if you need the visual representation, it's an option. All right. Now, we were dealing with triangle congruence shortcuts, and we have 5 of them. So instead of showing that all 3 sides and all 3 angles are congruent to this other triangle, we can actually get away with a little bit less. We can actually just show the 3 sides are congruent to the 3 sides, or 2 sides and 2 sides and an angle in between, like all these different things, right? So let's just kind of generically draw a couple triangles like we did last time and just talk about what information is needed for each of these things. All right, so now for side, 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 something that people get confused about here is they think, oh yeah, side, side, side just means I have 3 congruent sides. There we go. This side is congruent to this side, is congruent to this side. That's side, side, side. That's not what it means. Each of these S's actually represents a pair of congruent sides where one side is in one triangle, the other side's in the other triangle. So one pair of congruent sides, that's one of our S's, another pair of congruent sides, that's our other S, and then a third pair of congruent sides. Oops, one too many lines. So that's what we're talking about, 3 pairs of congruent sides. So that would be SSS. That would be enough for us to say these 2 triangles are congruent by side, side, side. Go ahead and erase that. I'm gonna undo that one. Okay. Next one, side angle side. So similar idea. These S's represent two pairs of congruent sides. So say this side here, and I don't know, this side here. And the angle, the A that is in between, represents a pair of congruent angles. But that angle has to be between the two sides. And it is, right? It's between the two congruent side pairs. We couldn't be talking about, say, for instance, if it was this angle, this is not SAS. This is two sides with an angle not in between that. SSA, we could call it side-side angle, or we could read it the other way, or not, right? This is not side-side-side. This is not a triangle congruence. The angle has to be in between the two known congruent side pairs. There we go. That makes it SAS. Just going to keep walking through these as a reminder. Feel free to fast forward if you feel like you got this. I don't want to. Let's just fix that triangle. Okay. The next one we have is angle side angle. So really similarly, angle side angle means that we have two congruent angle pairs. So whichever two angles we choose doesn't matter so much. So this angle pair and this angle pair. And then since the S is in between, means that the side has to be between the two angles. The side has to be between the two angles. That makes it ASA. So this would be ASA. If that side is not between the two angles, let's say it's this one and this one, that makes it AAS, where we have two congruent angle pairs and a side that is not in between. These are different from each other. Very small distinction, but they are different from each other. Now, technically, if you can use ASA, you could also use AAS. There's a way to do it because whenever you have two congruent angles, you could actually use what's called the third angle theorem to say that these two angles are also congruent to each other. And then now we have angle side angle. And now we have angle side angle. So you could technically, anytime you have one, you could use the other. But why do the extra steps? If you're given this information, or you can show this really easily, just use AAS. Or if you're given the other information, just use ASA. Whatever is easier. Now, one important thing with this is it doesn't happen with ASA. ASA have the sides in between, definitely corresponding. But something that can happen with AAS is you have two angles and a side not in between. There's two sides that are not in between. So perhaps this side was congruent to this side. In this case, this side over here does not correspond with that one. So even though both of them are technically AAS and AAS, these two sides are not corresponding to each other. So this would not be AAS. We need to be careful when we're doing AAS that the side actually does correspond. Because just being congruent is not enough. You could create a triangle like this, and these two triangles would not be congruent to each other. Last one, hypotenuse leg. I suppose I should have drawn some right triangles here, but let's just use our imagination. Let's just assume this is a right angle. Doesn't really look like it, but we're going to get away with it for now. So for hypotenuse leg, it is very important that we have a right triangle, because otherwise we don't have a hypotenuse. So we can only use hypotenuse leg for right triangles. So that is important. And then hypotenuse leg means that the hypotenuse of one right triangle, so the hypotenuse is always across from the right angle. So the hypotenuse, that's this one. The hypotenuses are congruent, and one of the legs. Doesn't matter which one. So it could be this one and this one. That would be an option. Could be this one and this one. Doesn't matter. One of the leg pairs. You'll notice hypotenuse leg is not one of these other things. It's not side, 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 because we don't have three pairs of sides. It's not side, angle, side, because the angle's not in between. It's none of these other things. It's its own thing. Actually, technically, it's side. It's sort of SSA, or right. It's one of those. But Those are not shortcuts for all triangles. So that's why we call it hypotenuse leg, because it only works for right triangles. All right, let's go ahead and take a look at a couple examples where we see which one of these will apply in a given situation. All right, so we have 3 pictures here. So something we want to keep in mind when we're doing triangle congruence, there are some things we can assume from pictures. So vertical angles. So anytime you have vertical angles, you want to make sure you mark those and kind of assume those. So right here we have vertical angles. So those angles would be congruent to each other. They're created by 2 intersecting lines. They're across from each other. They are going to be congruent. And then also here in this picture, we have a shared side, a side that is part of both triangles. It's going to be congruent to itself. So this side is the same in both triangles. Those extra pieces of information will give us enough to apply one of those shortcut theorems. Now, for this first one, we have one pair of congruent sides, another pair of congruent sides, and in between them, congruent angles. So that's SAS. Here we have one pair of congruent angles, another pair of congruent angles, and a congruent side, not between the angles. So AAS, that S is not between. If it was between, it would be ASA. And then the last one, side, side, side. We have one pair of congruent sides, another pair of congruent sides, and then a shared side, which is congruent. So SSS. All right. So that's the easy stuff. That's identifying those corresponding parts, figuring out which shortcut may apply in a given situation. What we're going to do now is create proofs, actually use those shortcuts to prove that 2 triangles are congruent in a full 2-column structure. All right, so here's our first example. I'm going to go through my full process the way that I sort of recommend that you do this. You don't have to do it like this if you already feel comfortable, but first thing I like to do is look at my triangles. What am I proving? Proving triangle KQB. So KQB, it's this one right here, is congruent to AQB. Okay, AQB. So these are the triangles we are trying to prove that are congruent. Really simple, not too difficult. Sometimes it's obvious. This case is pretty obvious what we were dealing with, but sometimes it can be a little tricky. They might overlap one another. Just know what you're doing. You don't have to outline it like this. Just make sure you do know what you're trying to prove. That's my first step. Second step, make sure that everything that is given to you is marked on the picture. In this case, it's not. So we got to go in there and we got to make some markings. So QK, it's this line right here, QK, is congruent to QA. Marked it. QB, this line, QB, bisects angle KQA. All right, so angle KQA is this big angle up here. It is being bisected, cut in half by this line. So that means that these 2 parts are congruent. So in the picture, angle 1 and angle 2 are congruent. This leads us to this marking, but our proof does need to include this congruence statement in it and an appropriate reason. So just this is not enough for that congruence. I do need to actually state that as an additional reason in my proof. So I will be saying in my proof somewhere that angle 1 is congruent to angle 2 because of the reason being an angle bisector. So the definition of angle bisector. Okay, cool. We're good. Third step. So that was my second step, marking the given stuff. Third step. Is there anything else from the picture that I can assume? Are there vertical angles? Are there shared sides? Are there parallel lines? Anything else that I can take to show that I have congruent sides or congruent angles anywhere? In this case, shared side. QB is common to both triangles, shared side. So I will be saying that QB is congruent to itself somewhere in this proof because of the reflexive property. reflexive property of congruence, because we're dealing with congruence here. Now, with all of those markings, do I have enough to say that these two triangles are congruent? Can I use SSS? Can I use SAS? Can I use whatever? In this case, yes. We have one pair of congruent sides, another pair of congruent sides that's shared, and a congruent angle in between. So this is going to be SAS. That was a terrible A. Let's do that again. This is going to be SAS. That is the way that I'm going to do this proof. Now it's about filling it out. I know how my proof's going to end. I know that it's going to be triangle KQB is congruent to triangle AQB by SAS. That's what we decided. That's what the markings tell us. That's all the information tells us. I also know how this is going to start. I always start with my givens. So I'm just going to list those out. Again, I like listing everything. Some people write them out as different steps. It doesn't really matter. I'm just going to write these are given. So this is my first step. I don't know what step that is. It comes later on. It's about filling in the middle. That's the middle part. That's what's tricky. So far, the only thing that I have definitively in my proof that's going to lead me to SAS is this pair of congruent sides. So I do have an S in my proof. Luckily, I wrote these out already, so I already know what I'm going to be using, but I already have my congruent angles and the reason that goes with it, my other congruent side, and the reason that goes with it. If I don't, I would need to figure that out. So I'm going to go ahead and move all that stuff over. Okay. Definition of angle bisector. That's my reason. Made it a little bigger, but okay. Just going to go with it. So that's my second one. That is my angle pair for SAS. My angles here. And that was step 2. The order here doesn't really matter. I could have done this step 2 or the next thing I'm going to do next. That actually doesn't matter too much. Last thing, I need to talk about this shared side. I need to talk about my third piece. So QB being congruent to itself by the reflexive property. Okay, that was my third step. And that was the third piece, the side pair for my SAS proof. So I have a congruent side pair, a congruent angle pair, a congruent side pair. They are arranged side angle side in my picture. I can apply SAS. That's it. Done. Proof is finished. The triangles are congruent by SAS, and I've shown it all in there with proper reasons. Feel free to pause it, look it over, think about it. All right. Second example. I'm going to go ahead and go through this one again. Same detail. So we are proving angle or triangle ADC. That's this one. Okay, ADC. And the other one is CBA. So CBA. Again, you don't need to outline it like this. Just helps make sure we know what we're dealing with. Make sure you know what triangles you're going to be proving that are congruent. That is an important piece here. Now, again, second step, like I did last time, are the congruent statements, are the given statements marked on my picture. Angle D is congruent to angle B. D, B. It wasn't marked, but now it is. AB is parallel to DC. I'll go ahead and mark that too. Okay. So identified what we're trying to prove. The two triangles are trying to prove congruent. I outlined those in pink and yellow here. Marked my givens in the green. Third step, is there anything else we can see from the picture? Vertical angles, shared sides, angles formed by parallel lines. Those are going to be Three real common things that we can see from a picture. What I see here is a shared side. That's straightforward, easiest thing. So I have an angle pair and I have a side pair. That's not enough. I'm looking for something else here. I notice these parallel lines. Anytime I have parallel lines, I need to be looking for any of those parallel line angles, corresponding angles, alternate interior angles, alternate exterior, whatever. Here we have our two parallel lines, our transversal AC. Angle 1 and angle 2 are alternate interior angles. They are on different sides of the transversal. That's what makes them alternate. They're different sides of this line here, AC, and they're both interior between the parallel lines. So these would be congruent because they are alternate interior angles. So angle 1 is congruent to angle 2 by alternate interior angles. That's it. Now that's enough, right? That's everything we needed. One angle pair that's congruent, another angle pair that's congruent, congruent side, not between the angles. This is AAS. So we're going to be using AAS for our proof. In fact, I know that's how my proof is going to be ending, AAS. I can go ahead and write the ending here, spoil the ending before I even get started. But that's okay. It's important to make a plan. Know how you're proving it. Very important. Okay. Again, I don't know what step number that is. We'll fill that in later. In fact, you don't even have to write step numbers. It doesn't really matter. Okay. We also know how our proof would begin. So these are both given. And okay, so sorry, I was just thinking about it here. This was one of my angles, one of my A's for my AS. I'll go ahead and name this next one here. So I'll say angle 1 is congruent to angle 2 by alternate interior angles. This one is a theorem. Remember, the one that is a postulate is the corresponding angles one. That's the one we call a postulate. The rest are all theorems. That's my second part. That's my second A. So that's those two. And then the S. What was the S? Oh, yeah. So this was shared side. So these are, this is going to be congruent to itself because it's the same name in both triangles. And that's the reflexive property of congruence. You could also write that it's a shared side if you wanted to. That's being more descriptive rather than citing a particular property, but that would be also an adequate reason here. Depending on how you want to number things, you could call this step 1 with our givens, step 2 here, step 3 here, step 4. Again, some people list the givens out separately, so this could be 1, 2, 3, 4, 5, but relatively short proof. We did everything. This was our side pair, AAS. You don't need to do this. I find this useful, though, in terms of just sort of keeping track that I did demonstrate each piece necessary for whatever triangle shortcut that I'm going to do. All right. Hopefully those weren't so bad, and hopefully you remembered how to do those things. You can try the Delta Math assignments that kind of go along with these ideas on there for the week 1 and week 2 assignment. Bye.